G'day, it's Rob here again. Well, in the last video I played around with metal casting using automatic transmission fluid and sand and a binding agent, and I used this as a former. I buried it up to that level there, and I cast up a piece of right angle stock like that, and it had the sort of finish you expect to get with sand. Not very flash really, but yeah, acceptable. You could machine that up with on the mill or something and get a decent finish. Anyway, that was the last video I did. And since that time I've been playing around a bit, and I made up a steel mould on the same lines as when you cast into a round cylinder, the aluminium shrinks and it will then slide straight out once it cools down and contracts. So I made up a mould, and it's actually worked pretty good, except that I did have a bit of a job getting it out of the mould. It shrank, and the mould, even though it was pretty accurately made, there obviously was a variation somewhere, and it probably that little bit there where it's tucked in. And anyway, I had a bit of a job knocking it out, so you know, maybe I'll revisit that. Anyway, so that was the Mark II version. Following that, I then moved on and I went to the Mark III version, which was this, where I cast up some right angle, and you got to say, not too bad. And this was a two-part mould. It's a mould that disassembles, and I just poured this one first. You can see it's got air bubbles here. Something went wrong there. Finishes what you'd expect, I suppose. Well, they're nowhere near as good as this finish. This was a lot better. But anyway, that was that. And then I went on to the next casting, but I heated the mould up. So when I had the mould warmed up, I then did the pour, and you can see, I think the finish is better on the inside anyway. So that was, yeah, I think that was moderately more successful. Still not perfect, and that would still need cleaning up with a fly cutter, but you know, as an exercise, it wasn't too bad. So I'll show you the mould I used. Okay, well here's the mould I made up, two pieces, and you can see that it forms a L-shaped channel. So we're pouring into this section here of the mould. This is the bottom of the mould. It would stand like that, and I would clamp it together with a G-clamp like this, just to hold it together, and do the pour in through the top. So it's standing basically in the sand like that, and I, with the G-clamp holding it together, and I do the pour. The mould actually is made up like this. Basically, you can see how it comes apart. So it's just made to go in, hook in and pull down like that, and then the clamp pulls it together. Got that? Pretty simple really. And it's just a bit of tack welded steel channel. Once again, it just goes together like that. Now you could make that any thickness you want, and I think that the success of this thick part compared to these pieces that came out of this is due to the fact that there is a lot more heat in this aluminium, and it's got time to flow better, whereas with the thin section, the heat's being taken out. Even though I've heated the mould up, the heat's being taken out a lot more quickly by the steel mould. So if I do this again, I think I'll make one that comes apart for this sort of size, and I think if that was the case, yeah, I think it's going to work quite well. The thin stuff I think is just too thin, even though it's about 5mm, I suppose. I think we really have to go this way to get a decent finish on it because of the heat transfer issue. But anyway, I thought I'd show you the mould, give you something to think about, how it works. It's yeah, pretty simple setup. It's just a bit of arc welded steel. I mean, once again, this is where the old stick welder, you can't beat them. I mean, get yourself one. They're so handy. You can fabricate all sorts of rubbish like this, and maybe, yeah, at the end of the day you'll get a successful cast. What am I going to do with these angle pieces? Well, I'll show you what the idea is. You would have seen in one of my earlier videos how I use simple pads for the jaws on the vise to avoid marking material, and for years and years I've used these steel ones. They're just made out of old soft steel, so they deform quite easily, but they stop the serrated teeth marking whatever I put in the vise. And they're just made out of soft steel, so I think old computer case, which is quite soft steel, and it works good. They're just so quick and easy to put in. The other thing is, if I'm holding a round section, it'd be nice to have a V section, but of course when you go V section, that means you need thicker metal, so you can't use steel really, you need to go alloy. So that the idea is that I would use a couple of these, and I would just machine a V into the face, have one on each jaw, and that way I could put round stock in there, and it would just, the V would hold it, and just take it off when you're not using it. This I think is too thin. If I put a V in there, well, it's going to go right through and it will probably just crack it. So this was just an experiment to see how thin I could go with this sort of steel casting technique. And yeah, as you can see, it actually, you can go pretty thin, but it's not really suitable for what I want to use. This is more what I want, so I'll cast up another, I'll cast up another one of these, and I'll mill it, put a V in on the front, just mill a V on the face on both of them, and I'll be able to use them for round stuff. So that's the plan. But I thought I'd show you how the casting is going, and certainly it's been pretty successful within my limited facilities, and yeah, I hope it gives you something to think about, and yeah, that's it. I'll see you next time. Cheers.